Hello, kids. Hello, kids. Hope you all are fine and doing good at home. So, today let's begin with a chapter: Is matter around us pure? Let us start. Hope you all know what is matter, and in this chapter, we have question: Is matter around us pure? Our matter can be classified into two types: pure substances and impure substances. Now, what is this pure substances? Pure substances are of two types. One is elements and second one is compounds. Impure substances, all mixtures are considered as impure substances. The term impure is different from adulteration. According to scientists, the term pure means single form of matter. Now, I would like to tell you what are physical properties of matter. Color, odor, density, melting point, and boiling point are often treated as physical properties of matter. The physical properties of a substance can be observed or measured without changing its composition. Let us have a look at the flow chart. The chart is about matter. It is about, can matter be physically separated? If it can be physically separated, that means it's our mixture. If it can't be physically separated, that means it's our pure substance. Now, about composition. What is the composition of this mixture? Is it uniform or non-uniform? If it is uniform, that means it's a homogeneous mixture. If it's non-uniform, that means it's our heterogeneous mixture. We have two types of heterogeneous mixture. One is glide and another one is suspension. Now, pure substance. Can it be chemically decomposed? Yes. When we can decompose the pure substance chemically, that means it's our compound. If not, that means it's our element. Have a look. Now the topic is types of mixtures. Mixtures are of two types on the basis of their composition: one homogeneous and second heterogeneous. Now let's understand what is this homogeneous mixture. Homogeneous mixtures are those mixtures which have uniform composition throughout. For example, mixture of salt and water, mixture of sugar and water, air, lemonade, soda water, etc. Mixture of salt in water is an example of homogeneous mixture. In this mixture, the boundary of salt and water can't be differentiated. And when a ray of light is passed through the mixture of salt and water, the path of light is not seen. Now we have charac- now we have properties of homogeneous mixture. First one is, all solutions are the example of homogeneous mixture. The particles of homogeneous mixture are less than 1 nanometer. A homogeneous mixture does not show Tyndall effect. The boundaries of particle can't be differentiated. The constituent particles of homogeneous mixture can't be separated by centrifugation or decantation. Alloys are the example of solutions. Now, Now we will move to our second type of mixture, that is heterogeneous mixture. Now what are these heterogeneous mixtures? Heterogeneous mixtures don't have uniform composition throughout. For example, mixture of soil and sand, mixture of sulfur and iron fillings, mixture of oil and water. The boundaries of constituent particles of heterogeneous mixtures can be identified easily. Now we have general properties of heterogeneous mixtures. First property is, most of the mixtures are heterogeneous except solutions and alloys. Second, the constituent particles are not present uniformly. Third, the components of the heterogeneous mixtures can be identified easily. Fourth, generally two or more phases are present in a heterogeneous mixture. Fifth, particles of heterogeneous mixtures are sized between 1 nanometer and 1 micrometer or more. Heterogeneous mixtures show Tyndall effect. Now, what is this Tyndall effect? Tyndall effect is the scattering of light by the particles. It is generally shown by collides. Now have a look at the diagram. It will give you the idea of particle distribution in homogeneous and heterogeneous mixtures. Now our topic is types of mixtures on the basis of their particle size. On the basis of particle size, we have three types of mixtures. One is solution, suspension, and collide. Diagram is given here. Check the diagram and understand the difference between solution, collide, and suspension. Now our first mixture is solution. Now what is the solution? It is mixture of two or more substances with one phase only. That is, having no distinct boundary of constituent particles. For example, solution of sugar and water, solution of salt and water, lemonade, soft drinks, etc. Solution is a homogeneous mixture of two or more substances. In a solution, components are mixed in such a way that they appear as only one phase, seen by naked eye. Constituent particles of a solution can't be identified because particles are mixed evenly throughout. In a solution, there are two types of components. One is called solute and other is called solvent. Now, what is the solute and what is the solvent? Solute, substance which is present in smaller quantity in a mixture is called a solute. Solvent, substance which is present in large quantity in a mixture is called solvent. Example is here, in a solution of salt and water, salt is present in small quantity while water is present in large quantity. We can say salt is our solute and water is our solvent. Example is solution of tincture iodine is made by dissolving iodine in alcohol. In this solution, iodine is solute and alcohol is solvent. Check the diagram. Now we have types of solution. We have so many types of solution. For that, you please check the table and try to understand. And I will explain few here. Our first type of solution is solid-solid solution. Now, what is the solid-solid solution? Solid-solid solution means both the solute and solvent in solution is in the form of solid. For example, our alloy. Alloy is a homogeneous mixture of two or more metals and non-metals or two metals or two non-metals. The components of an alloy can't be separated by physical methods. Their boundaries are not distinct and they can have variable composition. Thus alloy is considered as solution. Next type of solution is solid liquid solution. Now what is the solid liquid solution? Solution of solid and liquid is called a solid liquid solution. For example, solution of salt and water. Now liquid liquid solution. Liquid liquid solution means both the solute and solvent are in the form of liquids. For example, solution of water and acetic acid. Now, gas liquid solution. What is this gas liquid solution? It is solution of gas into liquid. For example, our soft drinks. In soft drinks, carbon dioxide is usually dissolved in liquid, because of which a hiss sound comes while opening the cap of the bottle. Now, gas-gas solution. Solution of two or more gases is called gas-gas solution. For example, air, which is the solution of many gases such as hydrogen, oxygen, carbon dioxide, neon, etc. This is all about the types of solution. Some characteristics of solutions. Solutions are homogeneous mixture of two or more substances, as everyone knows. Constituent particles of a solution are mixed evenly throughout. There is only one phase in a solution. Boundaries of the constituent particles can't be distinguished. The size of particles of a solution is smaller than 1 nanometer. Solution do not show Tyndall effect because small particles of solution do not scatter the ray of light. Solute can't be separated by using filtration. Some characteristics of solutions. Solutions are homogeneous mixture of two or more substances, as everyone knows. Constituent particles of a solution are mixed evenly throughout. There is only one phase in a solution. Boundaries of the constituent particles can't be distinguished. The size of particles of a solution is smaller than 1 nanometer. Solution do not show Tyndall effect because small particles of solution do not scatter the ray of light. Solute can't be separated by using filtration or decantation. Solutions are stable since when left undisturbed, the particles do not settle in bottom. Now we will move to our next topic. The topic is saturated and unsaturated solutions. What are saturated and what are unsaturated solutions? Saturated solution. When a solution can't dissolve more solute at a given temperature, the point is called the saturation point of the solution and the solution is called a saturated solution. This means no more solute can be dissolved in a saturated solution at a given temperature. The unsaturated solution. Unsaturated solution is a solution in which more solute can be dissolved at a given temperature. Now we have one more term which is important in solutions and the term is solubility. What is the solubility? It is the amount of the solute in a saturated solution at a given temperature, or we can say it is the maximum capacity to dissolve a solute in a solution at a given temperature. Different solvents can dissolve different amount of solute. That means different solvents have different solubility. Our solubility increases with increase in temperature. Concentration. Concentration is the amount of the solute present in a given amount of the solvent or solution. Concentration, we can write it like it is the amount of the solute divided by amount of solvent or amount of solute divided by amount of solution. Concentration is the ratio of amount of the solute and amount of the solvent. Concentration can be expressed in mass percentage or volume percentage of a solution. We have one more. Now, how to find the mass percentage of solution? We have formula for it. It's equal to mass of solute divided by mass of solution multiplied by 100. This means when concentration is expressed in mass percentage, it is called a concentration by mass percent. A second one is volume percentage of solution. For volume percentage of solution, we have also formula here. It is equal to volume of solute divided by volume of solution multiplied by 100. This means when concentration is expressed in volume percentage, it is called a concentration by volume percentage. Now we have second type of mixture on the basis of particle size, and the mixture is suspension. Now what is this suspension? It is a heterogeneous mixture in which the solute particles do not dissolve but remain suspended throughout the bulk of the medium. Particles of a suspension are visible to the naked eye. Example is mixture of chalk and water, dust particles and air, fog, muddy water, etc. The properties of suspension. Suspension is a heterogeneous mixture. The particles of a suspension can be seen by the naked eye. The particles of a suspension scatter a beam of light passing through it and makes its path visible. The solute particles settle down when a suspension is left undisturbed, that is, a suspension is unstable. They can be separated from the mixture by the process of filtration. Now, our last mixture is colloidal mixture, or we can say colloidal solutions. Now, what is this colloidal solution? A colloidal solution, occasionally identified as a colloidal suspension, is a mixture in which a substance is regularly suspended in a fluid. A colloid is minutely small material that is regularly separated out all through another substance. Example is whipped cream, milk, jelly, colored glass, etc. Now we have properties of colloid. First property of colloid is a colloid is heterogeneous mixture. The size of particle of a cloud is too small to be individually seen by naked eyes. Clouds are big enough to scatter a beam of light passing through it and makes its path visible. They do not settle down when left undisturbed. That is, a cloud is quite stable. They can't be separated from the mixture by the process of filtration. The components of a colloidal solution are the dispersed phase and the dispersed medium. Like in solution, in true solution, we have solute and solvent. The solute-like components or the dispersed particles in a colloid form the dispersed phase, and the component in which the dispersed phase is suspended is known as dispersing medium. Colloids are classified according to the state, like solid, liquid, or gas, of the dispersing medium and the dispersed phase. Colloidal solutions have three subclassifications: foam, emulsions, and sol foam. Kids, common examples of colloids are given in the table. Check the table. Kids, this is all about is matter around a sphere. Take care of yourself and take care of your family. Stay home, stay safe. Kids, this was all about